All right, leaning to turn. We see motorcycles leaning to turn. So in this case, we take into consideration that the object has a mass and has dimensions, right? And it takes advantage of these dimensions to push the ground on a certain angle. Okay, this is the first time we see something about dimension, but we avoid to talk about it a lot. So what happens is every time somebody wants to turn, and it has to lean towards the direction of the center. So the center of the circle is somewhere here. That means again that the radial axis should be horizontal. This is the radial axis. And of course we have the perpendicular. This is the center of the object. And the forces are the force due to gravity. We have the tension, and as we said, by leaning, we push the ground towards this direction, so the ground pushes us back towards this direction, so the normal force will now be like this, creating an angle theta with a horizontal. I get the horizontal. I could use the other one. It's the same. Again, I have to find, do we have any more forces? Well, if there's friction, friction should be in the third axis, the third dimension, so we don't care about it right now. Why? We don't see three-dimensional problems here. Any other forces? We don't care for air resistance. We don't have strings. No more forces. Again, two forces. And the one of them is not on the axis. So I should resolve the normal force, again, by doing it here. Besides the force due to gravity, I should have the R component of the normal force and the Y component, the normal force. Apparently, if I use it as a triangle, if I do the triangle to see, this is the normal force, this is the Y component, this is the radial component, and the angle theta is here, meaning that well, I use a lot of R's. Let's keep the capital R. So the radial component is the normal force times cosine theta, while the Y component will be the normal force times sine theta. I don't know the normal force. I don't know anything anyway. Well, I will, as always, I will keep the same steps, and at the end I will have a formula, and whatever they ask, whatever they give, I can use that formula. So the idea is to learn the steps. All right, so 1, 2. We do know that the sum of forces on the radial axis should create the centrifugal acceleration, and so this centripetal force is the radial component, F and R, while the sum of forces on the y-axis should be 0, meaning that the y component should cancel out the force due to gravity, mg. Okay, so I want a tangent. That means that let's start from 2. So I want to combine 2 and 4. From 2 and 4, I find that normal force sine theta equals mass times the acceleration due to gravity. 2 and 4. From 1 and 3, I find that from 1 and 3, I find that the normal force sine theta cosine will be the centrifugal acceleration mv squared over r. Now, by dividing these two equations, again, I have that normal sine theta over normal cosine theta equals mg over mv squared over r. Getting rid of the masses, the mass does not matter again. I do find that the tangent of the angle theta will be gr over v squared. And that's in the conical pendulum, I found exactly the opposite. I found that tangent theta equals v squared over gr just because the angle was with the vertical. Now I use the angle with the horizontal. But again, I come up to the same formula. Again, I see in this case that the relationship between the angle it needs to lean, the speed, and the radius of the circular motion are connected through this equation. Again, usually they give us the speed and the radius and ask for the angle, or they may give us the angle, they might give us the radius and ask for the speed, and usually they ask for the angle. They say, okay, so if we want to do a certain turn of radius 100 meters, and we want to do it with a speed of 50 meters per second, what is the safe angle we can use, we can lean, to make sure that we do the circular motion, we do the turn